Right, so this is another past exam question. So this is an Edexcel question, Further Maths FP3, June 2012, and this was question 5 on that paper. So let's have a read. Part A, differentiate x, r hyperbolic sine 2x with respect to x. So r hyperbolic sine means the inverse hyperbolic sine of 2x. So let's differentiate that with respect to x. So let me copy down the function here. So we have x, and instead of r, let me write it out as hyperbolic sine inverse 2x. And to integrate this product, we need to use the product rule. So in this case, let me write down the product rule. So by product rule, so remember the rule, d by dx of uv, and that is v du over dx plus u dv over dx. So here's the product rule. So with the product rule, I'm going to take my u to be x and my v to be the inverse hyperbolic sine 2x. So if I take a red pen, my u, I'm going to take that to be x. My v, I'm going to take that to be inverse hyperbolic sine 2x. So if I go back to my favourite colour, I'm going to do a side calculation. So now u is x, and we need du over dx for the product rule. So that would make, so let me scroll further down a little, du over dx would be 1. Now, next part, v. Now v I've chosen, as you can see, to be the inverse hyperbolic sine 2x. And let's have a look at dv over dx. Now, if you're unaware in terms of differentiating inverse hyperbolic sine terms, I have created a video in the past explaining the process along with added examples, and I'll provide a link to that video in the description below. But when you differentiate, so let me write down the result here. If you calculate d by dx of inverse hyperbolic sine x, you should get 1 divided by the square root of x squared plus 1. So as I said earlier, there are videos that I've created in the past, but there's also a video proving this result. So I'll provide links to all of those videos in the description below. So looking at this result, we're going to have 1 over, so it's 1 over. If I replace the x by 2x, so replacing the x's here by 2x will give us 1 over the root of 2x within a bracket squared plus 1, but you need to multiply by d by dx, the derivative of 2x, the argument. So that is in accordance of the chain rule. Now moving on, d by dx of 2x is 2. So if I continue further, so let me scroll down slightly, and let me continue over here. So that would make dv over dx. So if I move further into the calculation, 2 times this one on top is 2. So it's 2 divided by, let me make this line as neat as possible. So it's 2 over the square root, and 2x squared is 4x squared plus the 1. So this should be the outcome for dv over dx. We're far from done. Let's replace this data into our product rule. So in this case, d by dx of u is x, and v in this case is the inverse hyperbolic sine of 2x. So let me copy that down, and that is equal to v being the inverse hyperbolic sine 2x so inverse hyperbolic sine 2x, multiplied by du over dx being 1, plus the u, so plus, and ru is x, multiplied by dv over dx being, so let's copy that down, so it's 2 over the root of 4x squared plus 1. So let's go one stage more and multiply brackets. So the inverse hyperbolic sine 2x times 1, let's leave that as the inverse hyperbolic sine 2x, plus 2 times x is 2x, all divided by the square root of 4x squared plus 1. So that should be the solution, I believe, to part A. So that covers part A. So once again, if you're unaware in terms of differentiating hyperbolic functions or inverse hyperbolic functions, as I mentioned, I will provide links to these videos in the description below. So be sure to check out these videos. Now let's have a look at part B. So part B is hence or otherwise, find the exact value of this integral. The integral between 0 and square root of 2 of r hyperbolic sine 2x, so r meaning the inverse hyperbolic sine 2x, with respect to x, given the answer in the form a, ln b plus c, where a, b and c are real. So let me do the calculation here. Let me copy down the integral. So we're going to integrate between 0 and root 2, and it's 0 and root 2 of r, which is the inverse hyperbolic function, 2x with respect to x. So to integrate any inverse function, we need to apply by parts. So we need to apply by parts here. So we're integrating inverse hyperbolic sine 2x, or 1 into the inverse hyperbolic sine 2x. So we need to use by parts. So first of all, I'm going to tackle the integral without the limits. So first of all, let me tackle the one without the limits. So the inverse hyperbolic sine 2x. And let me write that integral as the inverse hyperbolic sine 2x multiplied by 1. So let me make it a product of two terms. And the reason for that is we're going to use by parts. So to integrate an inverse hyperbolic function, we need to apply by parts. And remember the by parts formula, integration of u dv over dx with respect to x, and that is uv minus the integration of v du over dx with respect to x. Now going back to my point, the reason why I wrote this as a product of two terms is because we need to choose u and dv over dx such that v du over dx is easy to integrate. So whenever you have an inverse function, always take u to be the inverse function. dv over dx then is the remaining term. So if I take a red pen, I'm going to take my u to be the inverse hyperbolic sine 2x. And if I take a green pen, then dv over dx is the remaining term, being 1. So if I go back to blue, so my u is the inverse hyperbolic sine 2x. And with the by parts formula, let's work out du over dx. So du over dx. Let's do this as a side calculation. Now for du over dx, so we did the calculation here, okay? That is probably the reason why they used the word hence. So when we differentiated inverse hyperbolic sine 2x, we had, and let me copy that down, 2 over the square root of 4x squared plus 1. So that is du over dx. Let me do another side calculation because we need v. Now dv over dx, I've chosen to be 1, the remaining term. So dv over dx is 1. So v in that case is the integration of 1. And when I integrate 1, I'll simply get x. Now that I know the data for the biparts formula, let's plug it in. So on the left hand side, we have the inverse hyperbolic sine 2x. So that is our u times dv over dx, which is 1 with respect to x. And that is equal to uv. Now u is the inverse hyperbolic sine. So let's replace inverse hyperbolic sine 2x multiplied by v, v being x, minus the integration of v, which is x, multiplied by du over dx, which is 2 over the square root of 4x squared plus 1. Let me put that dx there. Now let me multiply the brackets, in particular on the right. So x times the inverse hyperbolic sine 2x, that being x inverse hyperbolic sine 2x, minus the integral of 2 times x is 2x, and it's 2x divided by the square root of 4x squared plus 1. So let me pause there for a minute. Now, in this case, we need to integrate this integral here. So let me take a different colored pen. Let me go back to red. Okay. And I'm going to call that integral number 1. And let me do number 1 as a side calculation. So let me do number 1 here. So for number 1, so that's the integration of 2x over the root of 4x squared plus 1 with respect to x. Now I can rewrite this as, so 1 over the root is the same as a negative half power, so I can rewrite that as 2x into 4x squared plus 1 to the power of negative half. So 1 over the square root is the same as a negative half power. And to integrate this very integral here, we can apply the method of substitution. So let's use the method of substitution. Now, if you're unaware of substitution, I have created videos on how we integrate using substitution, and I'll provide links to those videos also in the description below. However, I'm going to take my substitution u to be 4x squared plus 1. So if I go back to blue, if I take u to be 4x squared plus 1, du over dx, so when I differentiate, du over dx is going to be 8x. Now if I move on from there, if I take the dx to the other side, du is going to be 8x dx. Now let me have a little stop and think moment. So this little star means a stop and think moment. And if we think about this, in our integral, we need to substitute or to replace a 2x dx. So we need to replace 2x dx. But at the moment, we have 8x dx. So we need to make this 8x dx a 2x dx to replace or substitute these two very terms. So if I go back to blue, to make this 8 a 2, we can divide both sides by 4, or you can multiply by a quarter. So all the same, dividing by 4, multiplying by a quarter, you're going to get a quarter du as a result. 8 divided by 4, or 8 times a quarter, is 2. So 2x dx on the right. So let me make that more clearer. So let me move on from there. Now as you can see, if I go back to my green pen, I do have a 2x dx, so here's my 2x dx. So it is then we can replace this 2x dx term by a quarter du, and also, just to add, we can replace the 4x squared plus 1 by u. So if we go through the substitution step, so by substitution, so let me continue below, so let me scroll down a little bit. So integration sign, let's rewrite this integration, so this integral rather, 2x and dx, so we can replace that by a quarter. Now a quarter I'm writing outside, so you can always write constants outside your integration as long as it's constant. Du always appears inside, so here's my du, and I've checked these two terms as I've replaced them. As for 4x squared plus 1, that is going to be replaced by u, so I'm going to get u to the power minus half. So don't forget the power of minus half. Now let's continue along the line, let's integrate this. So I have a quarter outside, so let me keep that a quarter outside. While I integrate u to the power minus half, adding 1 to the power is u to the power plus half divided by half. So add 1 to the power, divide by the result of adding 1 to the power. And just for completeness, let's add a c. So if we simplify this, if we tidy this up, so a quarter divided by half is the same as 2 over 4. 2 over 4 is a half. So we're going to get a half u to the half, which is the same as the square root of u, add c. So this should be the solution so far to this integral, but let's just replace the u just to complete. So if I replace u by 4x squared plus 1, so let me just add, since u is 4x squared plus 1, so by doing the replacement we're going to get a half, so half into the square root of u, which is 4x squared plus 1, add c. So this should be the solution to this integral here, number 1. But let's rewrite our solution here, the solution to the main integral. So let me continue below. So on the left we have the integration of inverse hyperbolic sine 2x. So let's copy that down. So inverse hyperbolic sine 2x with respect to x. And on the right hand side we have x inverse hyperbolic sine 2x. Let's copy that. So x inverse hyperbolic sine 2x. And it was a minus the answer of 1. So minus, and the answer of 1 is a half into the square root 4x squared plus 1. Okay, and plus c just for completeness. So let me make it clearer. So plus c. So this is the answer to the integral without limits. However, our integral has limits 0 and root 2. Okay, so let's include these limits. So let's include the limits of 0 and square root of 2. And in this case, that means that the answer of the integral in question, so if I replace the limits into the whole answer, so let me copy the x inverse hyperbolic sine 2x minus half, and it's a half root of 4x squared plus 1. And let's put the limits here, so root 2 and 0. If I firstly, so let me continue down here, firstly replacing the upper limit, so x is root 2, hyperbolic sine inverse, 2 into x, which is root 2, minus the half into the root of 4 into x replaced by root 2, so it's a root 2 squared plus 1. So that is what it should have upon replacement of the upper limit being root 2 minus, and let's replace the lower limit, which is 0. So x is 0. So 0 into the inverse hyperbolic sine of 2 into 0 minus the half into the root, so into the root of 4 into 0 squared plus 1. And let's tidy this up. So in this case, let me continue over here. So continuing over here, so if I continue on this space here, so we have root 2 hyperbolic sine inverse 2 root 2. So we have a root 2 hyperbolic sine inverse 2 root 2. And root 2 squared is 2. 4 2's are 8. Plus 1 is 9. Root 9 is 3. So we have a minus 3 over 2. So this is what we have when we tidy up the first bracket. Minus, as far as the second bracket is concerned, 0 times anything is 0. But don't forget, you've got 4 into 0 squared plus 1, which is 1. Root 1 is 1. So you got a minus half times 1 times this minus here. So I'm going to keep it as minus half for now. This is what we have only for the second bracket. And if we tidy it up further, so moving on to the next line, getting rid of the brackets, root 2 inverse hyperbolic sine 2 root 2 minus 3 over 2 plus half is minus 1. And we're far from finished because we need to write our answer in the form of, going back to the question, a, l and b plus c, where a, b and c are real. So let me show you how that is going to be done. Now to do that, if I take my red pen, we need to use the definition of the inverse hyperbolic sine x. So let me write the definition here. So remember, the inverse hyperbolic sine x has the following definition. It's ln x plus square root of x squared plus 1. So we need to use this definition in order to rewrite our answer above. So let's follow through. So that is equal to the root 2 from here. So let me copy down that root 2. If I replace the x's in this definition by 2 root 2, we're going to have ln x's replaced by 2 root 2. So this x is replaced by 2 root 2 plus square root of x squared. X is 2 root 2, so we'll have a 2 root 2, don't forget to square, plus 1. So let me close that bracket. Minus this 1 from outside, so minus the 1 from outside. So let me continue further. So we have root 2 ln, in this bracket we got 2 root 2 plus 2 root 2 squared, so that amounts to an 8. 8 plus 1 is 9, and root 9 is 3, minus this 1. So this should be the solution to this particular part, part B. So it was a big, meaty question. So if you're unaware of the principles used to do this question, I will provide links to the videos that I've created in the past in the description below. However, if you enjoyed the video, be sure to like and subscribe, and I hope to see you again. Thank you.